Okay, let's try out a few more examples. So here we have, I'm going to call these matrices C and D. We have a 2 by 3, so 2 rows, 3 columns, multiplied by a 3 by 2 matrix. Okay, notice that the number of columns of C is equal to the number of rows of D. And so the product makes sense. And it will be a 2 by 2 matrix. Alrighty, so let's try this out. Okay, so let's try and do this work all in one place. We're going to begin by working on the first column. Okay, so we're going to be taking the matrix C and multiplying by this vector 1, 5, -3. Okay, so in order to do this, we're going to take 1 times 1 plus 2 times 5 plus 3 times -3. So this is going to be our first entry, the first row, first column entry we get by multiplying corresponding entries in the first row of the matrix C with the first column of the matrix D. Okay. To get our next entry, we're going to take, to get the entry in row 2, column 1, we'll take 4 times 1 plus 5 times 5 plus 6 times -3. Okay, so this is going to produce our first column. Our second column we get by taking the matrix vector product of the matrix on the left, C, by the second column. So to produce the second column, we're doing a matrix product with the second column. So the column we use is going to come from the matrix on the right. And we're going to be doing these computations to find with the rows of the matrix on the left. So to find the entry that lives in row 1, column 2, oopsie, we're going to take the row 1 of the matrix on the left with column 2 of the matrix on the right. So we have 1 times 0 plus 2 times -2 plus 3 times 7. To get the entry that lives in row 2, column 2, we'll take 4 times 0 plus 5 times -2 plus 6 times 7. Okay, and so this will be 1 plus 10 minus 9, 4 plus 25 minus 18, and then 0 minus 4 plus 21, and 0 minus 10 plus 42. It's good to write out this arithmetic. So 1 and 10 minus 9 is 11 minus 9, or 2. 25 minus 18 is 7. 4 and 7 is 11. 0 minus 4 plus 21 is 17. -2 plus 42 is 32. Okay, and we have our result. Let's take a look at what happens when we multiply the same matrices in the opposite order. So we have a 3 by 2 multiplying a 2 by 3, and the result is a 3 by 3 matrix. Okay. All right, so to get the, we can do this one column at a time, or we can actually think about them entry by entry. So to get the entry that lives in, for example, row 2, column 3, we would take row 2 of T with column 3 of the matrix on the right, C. Okay, let's work through these. Okay, so let's work down our columns first. So we're going to be taking this matrix multiplied by the first column vector, 1, 4. So we have 1 times 0 plus 0, oh, nope, 1 times 1 plus 0 times 4. Okay, so we're beginning by doing this product, 1 times 1 plus 0 times 4. Then we have 1 times, or 5 times 1 plus negative 2 times 4. And then negative 3 times 1 plus 7 times 4. This is going to be column 1. Next, we're going to look at column 2. We have 1 times 2 plus 0 times 5. Next, we move down to row 2. So we're producing the row 2, column 2 entry of the product. We have 5 times 2 plus negative 2 times 5. The row 3, column 2 entry is going to be negative 3 times 2 plus 7 times 5. Right, and we have one last column to do. So we're taking the product of this matrix with column 3, which is entries 3, 6. So in row 1, column 3, our entry is going to be 1 times 3 plus 0 times 6. Row 2, column 3 is going to be 5 times 3 plus negative 2 times 6. And then row 3, column 3 is going to be negative 3 times 3 plus 7 times 6. All right. And now we're just going to do this arithmetic. I think taking it a little bit slowly is helpful because it's easy to make mistakes. One really common place to make a mistake in this arithmetic is when you have 0 times something. Remember, it'll be 0. So we have 1 plus 0. We have 5 minus 8, negative 3 plus 28, 2 plus 0, 10 minus 10, negative 6 plus 35, 3 plus 0, 15 minus 12, negative 9 plus 42. Okay. And now we can finish this arithmetic. We have 1 plus 0 is 1, 5 minus 8 is negative 3, negative 3 plus 28 is 25, 2 plus 0 is 2, 10 minus 10 is 0. Negative 6 plus 35 is 29. 3 and 0 is 3. 15 minus 12 is 3. Negative 9 plus 42 is 33. All right, and so this is our matrix product. Notice that changing the order of this matrix product produces a completely different matrix, even if these matrices are the same size. So if we have square matrices where the dimensions are equal, in general, with matrix multiplication, AB is not going to be equal to BA. Good job.